बाबा सांग बाबाजी असं सांग.
Okay, guys, good evening to all of you. Let me share the screen. Okay, is the screen visible? Can you just let me know? Is the screen visible, guys?
Yes, sir.
Yes, sir.
Okay. Uh, just let me just confirm it. When I change the screen to this other, is it changing with other screen? Is it now Spectra? Something different?
Yes, sir.
Okay, good. Now look at here. This is the last spectrum which we have discussed, and how to write exactly in the examination. That pattern also I have given to you in the PPT. So once again, I will have just a discussion about this spectra. Now, when the spectrum will be given to you, so that spectrum will include all five spectroscopy, including UV, IR, NMR, that is C13, and proton NMR, as well as mass spectrum. So the first of all, you have to comment on the molecular formula. So this molecular formula C9H11NO2 includes how many double bonds? That molecular formula includes how many double bonds? That you have to comment first. Okay. So now this screen with the writing, if it is visible, let me know. Okay. Is the screen is visible that I am doing some writing stuff? Just let me know. Okay, hopefully it will be. Now look at here, the spectrum 9, C9. Look at here, this one I will just write here. C9H11 and O2. Now, if you want to calculate the degree of unsaturation, as I told you, if you add 1 unit in a carbon, that is a C10, okay, minus, take the half of the hydrogen. If the nitrogen or halogen is present, always you have to take, if nitrogen is present, -1 from the hydrogen number, so it will be 10. And if halogen is there, then you have to add 1 in the hydrogen number. So in case of this molecular formula, so you are going to -1 from hydrogen number. So the hydrogen number will be 10. 10 by 2, that means 5. So 10 minus 5, so this will be 5. So degree of unsaturation for this compound will be 5. So that means there is a presence of double bond in this compound. Now, if the degree of unsaturation is more than 4 degree of unsaturation, so there are some tricks. If there is a degree of unsaturation more than 5, is the screen visible to all of you? Writing screen? Just comment anyone. Okay, hopefully it is. Now this is a 5 degree of unsaturation. That indicates there is a presence of aromatic ring, because the aromatic ring includes how many double bonds? There are 3 double bonds, no doubt. and one ring structure. So it counted 1 degree of unsaturation. So total degree of unsaturation for the aromatic ring will be 4. So 4 degree of unsaturation will be for aromatic ring, and maybe one another double bond is present in the form of maybe the carbonyl group, or it may be the olefinic double bond that we have to work out. Now this structure already we have discussed in the last lecture, but uh, as such, the structural elucidations we did not comment in a proper sense. So that's why I choose this structure to comment again. So if you see here, from molecular formula, it is very much clear there are 5 double bond present. And how we have justified that 5 double bond? 4 maybe from aromatic ring, and 1 may be the olefinic double bond, or it may be the carbonyl double bond. So this is the comments. Now let's see the UV spectrum. From the UV spectrum, I told you how to calculate the epsilon value. So this epsilon value can be easily calculated by the ratio of molecular weight into absorbance upon concentration and path length. You can easily calculate the epsilon value. From the epsilon value, you will come to know whether there is extended conjugation or not. So if you do this, you will come to know there is a 1700 epsilon value which we have calculated already. And from this spectrum, UV spectrum, you come to know there is a presence of N to pi star transition, pi to pi star transition, and epsilon value is 1700 and above. So that means there is extended conjugation. That type of informations you got it from the your UV spectrum. Now look at here your IR spectrum. The IR spectrum will give you the 2 peaks over here in the range of 3400. So 3400 2 peaks, that is a prominent for the NH stretch. So in the molecular formula, there is a nitrogen present that indicates there is a presence of maybe nitrogen stretch, nitrogen hydrogen stretch, that is maybe the part of your amino group. So amino group may be present. That informations you will get it from the your IR spectrum. Other informations from the your particularly this stretching frequency, which is above 1600, that is up to 1700, that is 1680. So this number is 1680, which is lower than the as usual carbonyl stretch. Normally, when the carbonyl group is in conjugation with the aromatic ring, so if this carbonyl group is in conjugation in the aromatic ring, then the carbonyl stretching frequency will go down. As well, if there is a possibility to have the amide group, okay, these all are the possibilities we are talking about. So if there is a amide group, so this amide group will have resonance or equilibrium between the single bond character formations. Why? Because this lone pair of electron induced in the carbonyl group in these formations, and this double bond will turn into this single bond because of this shift of the electron. And most of the cases, this amide stretching frequency is amide carbonyl stretching frequency is lower than the expected one. So this may be the possibility, because we are showing the possibilities in the beginning, and then we have to come to the conclusion about the structure. So we got this stretching frequency of the carbonyl group. So this may be the amide stretching, as well as this amide may be in conjugation with the aromatic ring. So this information we collected from the IR spectrum. Now come to the PMR, proton magnetic resonance. What is proton magnetic resonance? Where you will get the exact information about the proton present, which is in connections with the other, that is a coupling. So if you see here, this is a triplet and this is your quartet. So whenever you come across with the triplet quartet pattern, that indicates there is a presence of CH3CH2 group. So this ethyl group is always confirmed. Now, moreover, the value of the quartet is 4 point something. That means this is attached to the O. So this group, ethyl group, ethoxy group is also confirmed. Now here, this is a doublet and this is a doublet. So this doublet of doublet is always the part of para substituted pattern in the aromatic ring. So if there is an aromatic ring present, and if there are the disubstituted pattern on the para position particularly, there is a possibility that this H and this H will be, this will be the doublet with this H, and reverse, this one will be the doublet. So you will have two protons doublet. This will be same, this will be same. So this will be two proton doublet. So this will be two proton doublet. This will be your two proton, no doubt, quartet, and this is a three proton triplet. This can be easily calculated from this integral value by just measuring this integral height by roller. Now let's see the C13 NMR spectrum. In the proton magnetic resonance, there is a one peak around 4, which is exchange with D2O. Now the exchange with D2O indicates there is a presence of maybe the active proton, and that active proton may be the part of hydroxyl group, or it may be the part of amino group, or maybe the carboxylic acid. So carboxylic acid is not there, alcohol is not there, because there is a doublet present over here. In case of hydroxyl group, this peak will be like a broad singlet BS, whereas this is a sharp peak, which is a doublet, and that indicates there is a presence of NH phase, and that to be NH2. So from this IR, it is confirmed that this OA, this particular peak belongs to the NH2 group. So this NH2 group has been confirmed. There is a presence of carbonyl group that has been confirmed by this switching frequency. Paradise substituted pattern is also confirmed from the PMR. There is a ethoxy group is present, that is also confirmed from the data we got it. Now let's see the C13 NMR, where the off resonance spectrum. Off resonance indicate that gives you the idea about whether the proton is coupled with the carbon. So this indicates there is a presence of quartet. This is a triplet. That means this will be CH2, this will be CH3, that is confirmed. And this is a solvent peak, that is a triplet, that is CdCl3 peak. Okay. And then these are the aromatic doublets, no doubt. This is a quaternary peak, a quaternary peak of this particular Paradise substituted pattern. And there is a peak around 1700. This will be the 17 something. So this will be the carbonyl stretch. So all the stretching frequency will be identified over here. So from this overall structural data, we come to know that there is a presence of ethoxy group. There is a presence of, no doubt, there is a presence of what we call as this is the aromatic ring with carbonyl group, and there is a NH2 group too. Now from this structural data, we have discussed in the last lecture that the D2O exchange is possible with the free NH2 group and not in the case of amide. So this presence of amide group in this structure will be ruled out, because if the amide group would be there, then there should not be any humps in the proton magnetic resonance, and that should not be exchanged with the D2O. That is the part. So if we ruled out this case, then left is what? Left is the structural unit left with us is there is a aromatic ring present. No doubt that aromatic ring is Paradise substituted. There is a carbonyl group. That carbonyl group may be in conjugation with the aromatic ring. So that's why the del value is less. Okay. And this particular ethoxy group may be the part of this carbonyl group. So this may be the ethyl ester. Okay. So these are the possibilities. Okay. Now, so this group, and there is an NH2 group. So if you want to confirm this, all that things, what you need to do, that there is a mass spectrum now. Now the mass spectrum indicates there is a M plus something like 165. Am I right? 165, if it is correct. This is something like, sorry, this 100 and this will be 65 or 85. Let me just get it from M plus is 65. Yes. So 65 is there, M plus. So just a minute. Okay, so this M plus is 65 minus 65 minus 137. If we work out this, there is a presence of 28 unit. So this 28 unit is because of the ethylene group, CH2CH2. Okay. Now, if the ethylene group is over there present, so that ethylene group is possibly goes out from this ethoxy group when this ethoxy group is attached to the carbonyl group. That means there is a possibility to have Mac-Lafferty rearrangement in the structure. For the Mac-Lafferty rearrangement, this ethoxy group should be attached to the carbonyl group. Then and then it is possible to have the Mac-Lafferty type of rearrangement. So if this is the fragment fitted over here, so this will be having, this is your alpha, then the beta, and then the gamma, and so on type of compound present. So this fragment is possible. Left is what? Amino group over here. So there is a possibility of this structure, or it may be the amide to this side and ethoxy group this side, to this side, that is ether. So we already discussed this structure. Let me just show you how we have did it. So these are the structural units we have calculated in the last lecture. This I will show you here in a proper sense. So these are the structural units, this paradise substituted, ethoxy group, carbonyl group, NH2 group. Now, possibility of the structure having maybe this structure or this structure. Now, if you want to compare this, if there is a possibility that if it is like a ester or ether, then for the ester, this value is 4 point something for the CH2, and for the ether, it will be 3.9. Okay, this is one thing that you can get the little bit idea. Another idea, already I have mentioned you, there is an amide group present. If there is amide group present, there would not be possible D2O exchange. So from this structure will be ruled out, and possibility this structure will be present. So this way you can easily confirm. And the major confirmation is through the this type of fragmentation, and that is a Mac-Lafferty type of fragmentation, and it is easily work it out. Okay, so this is already we have discussed. Now let's see the another structure which is number I would like to discuss with you, that is 124 structure. Okay, let's see this 124 structure. Now this structure is having similar type of the unit 124. Okay, now just now we have discussed about the ester with amino group. Okay, so that is sort of paradise substituted pattern. Now if you see 124 structure, it is sort of similar type of thing. So let me just copy this for further workout. If you see here now, okay. Now look at here, how to read this spectrum now. First of all, we are going to talk about the molecular formula. So how many degree of unsaturation is there? So it is very easy, 9 plus 10, 10 minus 5. So it will be again 10 minus 5, again 5 degree of unsaturation. Okay, so 5 degree of unsaturation, if it is there, then it is confirmed there is a presence of aromatic ring. So this is the one thing. Okay, so there is a presence of aromatic ring because degree of unsaturation is 5. Now comment on the IR spectra. What is there? 3400. That is a nitrogen and hydrogen stage that confirm there is a presence of NH stage, because in the molecular formula there is a nitrogen. Okay, so that NH2 group is also confirmed from this. Now come to the IR switching frequency. There is a carbonyl group present in this molecule too. Okay, so from the IR, what informations you will get? There is a possibility to have epsilon more than 10,000, because this epsilon 10 to the epsilon value log to the base 10 epsilon is 4.2. So whenever the value of epsilon log to the base 10 is 3.8 and above, up to 4 or 4.5 or 5, so that means there is extended conjugation possible. And these are the possibility of pi to pi star transition, and this is n to pi star transition. So these are the two possibilities of the transition present in this molecule as there is a presence of carbonyl group. So that comment is sufficient. So there's higher switching frequency is there. That is a nitrogen switch 3400 and then carbonyl switch. That is enough for this. Further values you can comment, that is a alkyl switch which is below 3000, that you can easily write it down. Now, next directly you can come to the proton magnetic resonance. In the proton magnetic resonance, you can see here, this is a doublet and this is a doublet. So that means there is a presence of paradise substituted pattern. So this aromatic ring is again in the format of paradise substituted. Now here, this hum is belongs to the nitrogen switch, that is NH2 peak. Okay, so this NH2 peak, which is again exchange with D2O. So there is a possibility that NH2 group, which is free, will not be the part of aromatic, will not be the part of amide. So NH2 amino group is free over here in this structure. What else we have here? So the aromatic part is over. The aliphatic part, there is a presence of, now DPT indicates that all are, it may be the CH or CH3 peak because there is no any negative peak. If there is no negative peak, what does it indicate? If there is no negative peak, that indicates there is a presence of what? The alkyl group. So alkyl group, so there is a presence of alkyl group, and that alkyl group is simply a singlet. You can see here, these are the singlet, and having, you can see here, the height of the both the singlet is almost same. Okay, height of the peak is almost same. So it is possibly there may be presence of 2CH3. So if 2CH3 are there, now count the carbon atoms. So there is a C9. So C9 means 3, 4, 5. Okay, and there must be another carbonyl group. Okay, so there is a presence of another CH3 over here. Okay, now what else? Yeah, 2 CH3s, their height is same. So 2 DPT also confirm there is no presence of CH2. So that means structural units are possibly aromatic ring disubstituted. There are 2 alkyl groups. There is a NH2 group. There is this may be NH or NH2. So this may be NH or NH2, and this is a carbonyl group. Now just count the number of carbon atoms. So 6 carbon over here because of the aromatic ring, 7, 8, and 9. So C9 is the molecular formula. So C9. Now count about the hydrogen number, whether they are fitted with this structural unit or not. So that is we call as a residual unit calculation. So 4 form aromatic ring, and 6 from your methyl group. Suppose there's a 10, and if it is a 2, then it would be a 12. So obviously this should be NH. So this NH2, as we have considered over here, if you see here, this IR also indicate there is a single peak. In the earlier peak, there was 2 peaks and 2 stretching frequencies were mentioned. But here only 1 stretching frequency is mentioned. So probably it should be the NH stretch. That means there is a presence of NH group. So if there is an NH group, that means it may be the possibility to have N-methyl group present in this structure, because this one, both the CH3 groups, they have in the singlet, and their values are slightly differ. That values are slightly differ in the range of 2 and 2 point, that is 2 point something like 2 or 2.5. So probably the one group is attached to the aromatic ring, another group may be attached to the your nitrogen. So what probably the structure? If you see here carbonyl group, so the carbonyl group may have attached with this. So there is a possibility to have the acyl group. Now this acyl group presence can be easily confirmed from the mass spectrum, that is 43 unit. So this 43 unit belongs to this group. So another peak, another group present, the structural units now. So paradise substituted, this acyl group must be there, and there is a presence of, no doubt, NCH3. So this group. So this NCH3 group is present. Now, there are three units. One is paradise substituted aromatic ring. This functional group is there. This functional group is there. Now, there is extended conjugations, that 4.2, that indicate this particular carbonyl group is directly linked to the aromatic ring. And that's why this particular epsilon value will be in the range of something like in the 1000 number. And that is log to the base 10e 4 point and above. So this acetophenone type of derivative, and obviously this group should be attached to the para position. So this way you can easily work out the structure and then comment on the structure based on the chemical shift value. So this will be singlet, this will be further singlet. Now this NH will not couple with the CH3, or CH3 will not couple with the NH. So both will be singlet, and this will be doublet and doublet, and overall structural features from the PMR and the C13 will be matches. And from the C13, you can easily work out how this fragmentation will proceed. Now this group, particularly 106 and 0.9, if you take the difference between this 43 minus this, that indicates after the loss of acyl group, this group, the remaining unit will be reflected over here. So that way you can easily work out their fragmentation and confirm the structure present in this from this particularly spectrum. Let's see another different type of structure now. Already we have discussed about the paradise substituted 2 examples. So I would like to show you something different structure, like take the example of 146, which is very simple, but it's not that simple. Number of times we do mistakes about this structure. Now look at here, this 146. This 146, if you want to elucidate what structural features you will get. Now look at here. First of all, you have to calculate degree of unsaturation from the molecular formula. So if we have a molecular formula, C3H7, obviously I told you when nitrogen is present, take -1 from the hydrogen number. So it will be 6. And hydrogen, add 1 in case of carbon. So this will be 4. 4 minus 3, it will be degree of unsaturation 1. So there may be the presence of 1 degree of unsaturation in the form of maybe the carbonyl group. So this 1654 indicates there is a presence of carbonyl group. Now this value is too much down, that is 1654. So that also gives some information about the structure, okay, or about the functional group. Normally the amide stretching frequency goes that much down in case of carbonyl compound. Now here there is a presence of 3300 stretching frequency. Obviously this will be the nitrogen hydrogen stretch. So from this it is confirmed there is a presence of carbonyl group, as well as this carbonyl group may be in conjugation with the amide, and this amide will have a single bond induction of the carbonyl group because of the resonance. So there is no significant absorptions in UV. That means there is a presence of maybe the pi to pi star and n to pi star, but it is not that prominent. So take the example of proton NMR. So there are the 2 peaks in the range of 2 to 3, which will be showing that there is a presence of one is singlet, another one is doublet, which is expanded over here. Look at here, expanded form. So this expanded structure is a doublet and looks like a doublet, okay, and this is a singlet, okay. But this particular expansion, it is not just because of the maybe the coupling of the proton, but it may be the proton having a different environment in the stereochemical form that we will discuss later. Now, if you see here in another 7.5 range, there is a 1 hum which indicates that there is a presence of the active proton which exchange with D2O. So that confirms there is a presence of NH2 group. Now, from the PMR, it is confirmed there is a presence of the two carbons, okay, two protons, probably two protons, which is having equal, almost equal stretching frequency, height of the PMR. So if I write here, look at here, this height is almost same. So that means this may be the three protons peak, or this may be the three protons peak. So that this is the meaning of that. Now these two CS3 groups are possibly present here, this one and this another one. So that we can mention over here. There is a presence of this NH, it may be the NH or NH2 group. Again, there is no doublet mention over here. So if there is a no doublet mention over there, that indicates what? There is maybe presence of NH. So this probably may be the NH, but there is a amide group present, because why? The carbonyl stretching frequency is 1654. Now further, C13 NMR. So that shows there are two carbon present, which is having enormous del values. So it may be this CS3 and this CS3 may attach to the carbonyl group, as well as maybe the nitrogen. Another stretching, another chemical shift value, which will be in the range of 170. So that may be the carbonyl, the del value of the this carbon, quaternary carbon. In this DPT, there is no presence of any CH or maybe the CH2. That means there is no negative peak. So this belongs to the CS3 and CS3. So from the structural unit, it is very much clear that the proton, which is having a 2 point something values like this one, should be attached to the carbonyl group. And the another, which will have close to 3, will attach to the your CS3. So this will be N-methyl acetamide structure, and which will show this type of structural unit. And from the C13, you can easily work out there is a presence of this group, that is a 43. There is a presence of 30 unit. Now the 30 unit is belongs to this N-methyl, and 58 belongs to, if I remove this group, so this will be 38. So 58. So that way you can easily confirm this structure. Now, all the structures where we got here molecular formula. Now, most of the cases, the molecular formula will be missing. So in that case, if the molecular formula is missing, how to elucidate the structure? That is the another type of problem sometimes the examiner will prefer to give. Number of times when I used to go to as an examiner, I prefer to do some calculation at home. What calculations? I will get the molecular formula support. So this molecular formula, I will convert into the, I will hide the molecular formula and I will convert that into the elemental analysis. So element like carbon present, hydrogen present, nitrogen present, oxygen present, halogen present. So all that percentage will be given. And from the percentage of the element, you can easily get the molecular formula. Sometimes you will get the empirical formula, and that empirical formula will be empirical formula weight will be compared with the molecular weight of the given molecule. If it is like a twice of the empirical formula, then empirical formula into twice, and then it may be twice, thrice, and then molecular weight of the empirical formula and the molecular weight given in the mass spectrum should match, and that many fold of empirical formula will repeat. And that type of information sometime will be given by the examiner, and that time you should be able to crack such types of spectrum. So let's see how that works out. So yeah, so this is simple one calculations. I have taken some slides from other from online sources. Now, what is this slide includes? Let me just comment on this. Now, if somebody asks you that this is the spectrum, just imagine I have given one spectrum and not mention molecular formula. So imagine, so I will just take any example as this example, and this molecular formula is not there. If the molecular formula is not there, so what informations will be given to you? The informations given to you will be this. The informations given to you will be this, that this compound, the molecular formula or this compound, which spectrum will be given to you, contain how many percentage of the carbon, how many percentage of the hydrogen. If the hydrogen and carbon is provided to you and not oxygen, okay, just imagine oxygen is not given, then what you have to do, you have to add this percentage of carbon and hydrogen. If nitrogen given, then nitrogen, and if oxygen is not mentioned, then you have to total of these. Total should be 100%. Okay, because it's in the percentage. If it is not 100%, then whatever number makes this, suppose this is like a 70 and this is 50, so roughly this will be 76 point something. Then you have to take the difference between 100 minus 76 point something. So that gives you the percentage of oxygen. Sometimes oxygen percentage will be given, sometimes may not be. So whenever you calculate the elemental analysis, that indicates your sample has been heated in the oxygen. So oxygen is required to burn that particular sample which contain carbon, hydrogen, and maybe the halogen or sulfur sort of thing. Their percentage can be easily worked out, but the oxygen required may not be given correctly. That element will not be found. So you have to take the difference from 100, whatever carbon, hydrogen, halogen is present, total it up and take the difference between the 100 and whatever left is your oxygen. Some problem they may give directly the percentage of carbon, percentage of oxygen and hydrogen. Suppose this is the example where it says 100 gram of the compound has been burned, and then we found that there is a 5.8 hydrogen, 70.6 gram of carbon, and 23.5 grams of oxygen. So how to calculate their millimoles? That millimoles or moles can be easily calculated. The given weight or given percentage. Percentage means in 100 how much grams is that carbon or hydrogen or oxygen present. So 76 divided by the molecular weight of the carbon. So that will gives you the number of this 5.8, that is a moles of carbon. So hydrogen, that is hydrogen is 5.89 divided by hydrogen weight, that is a 1.008. Sometimes we consider as a 1. So 5 divided by 1, that is a 5, same number, almost same, because accurately it will be 1.008. So it will count to 5.843 moles of hydrogen. Oxygen atomic mass is 16. So 23.5 divided by 16. So this is simply this divided by 16, this divided by 1, this divided by 12. So that number is this. So whatever numbers of millimoles or moles you got it here, the lowest number is this. So you have to divide all three numbers by the lowest number. So this 5.8 divided by 1.4. So this gives you 4 as a carbon. Then 5.8 divided by 1.4, that roughly comes to 4, hydrogen 4. And 1.4 divided by 1.4, that should be absolutely 1. So from this data, it comes to know that there is a presence of C4, H4, O, and this will be the empirical formula. This is called as empirical formula. And its weight, you have to calculate the weight. So the empirical formula weight means the atomic weight of this carbon, this hydrogen, and this oxygen, that. And if the molecular weight of this compound is given, so divide this molecular weight upon empirical formula weight. So that gives you the number n, and that n is equal to how many times this is repeated. So if it is twice, thrice, and that will give you the exact molecular formula of this structure. Okay. So in this case, this is the empirical formula, and from the molecular weight, you can easily get the molecular formula of this compound. Let's see how to do that from the other slide. Look at here. This is one slide over here, indicates there is a similar type of calculation now. This X compound contained molecular mass is 230. Molecular mass is 230. Now, if the molecular mass is 230, Okay, so this imagine molecular mass is 230, that is the molecular weight. Carbon contains 62%, hydrogen content 9.63%, oxygen content 27%. Just imagine oxygen is not given to you. Then what you will do, add these two together and minus from 100 this value. So that will be your hydrogen, because this is a total is 100%. So this way you can easily calculate the oxygen percentage also. Always, if oxygen percentage is not given, that means you have to calculate. If it is given, well and good. If not, then you have to calculate by adding the carbon plus hydrogen and take the difference from the 100, because it's a percentage. Now, how to calculate again the same given mass? Suppose given percentage, that is a mass. So upon their molecular mass. So obviously 62 divided by 12, 9.6 divided by 1, 27 divided by 16. So that numbers comes to 5.2, 9.3, 1.7. The lowest number is 1.7. So divide the lowest number to all number. So 5 divided by this 7.4. So that gives you carbon as a 3 number. Divide 9.53 by 174. So that number comes 5.5. Divide 1.4 upon 1 point, that should be 1. So you got here empirical formula C3, H 5.5 and O 1. So there will be never 5.5 hydrogen. It must be an integer number. So this is an empirical formula. Now this empirical formula will have certain weight. Suppose molecular weight is 230 and their empirical formula is less. So what you are going to do, you will multiply this with the number. It may be twice or thrice or 4 times. So if I multiply by this with the 4, that is so let's see here. Just imagine empirical formula now, how to calculate. Now we come to know that from this calculation we got here this, and this, and here this is 5.5. So that does not mean this is the empirical formula too. So empirical formula should be twice. So if I make it twice, this should be C6. So this is C6, this should be 11. So 11 and O will be twice. So this becomes now empirical formula. Now this empirical formula mass is 115.17. So that means this empirical formula is twice to that of the molecular formula. So if I make it twice, it will be 12, C12, H22 and O4. And this become a molecular formula. If I count the molecular weight of this, it will be 230. And the empirical formula weight is half of the molecular formula. That's why I had to repeat twice of this. And then it becomes the molecular formula. So from the molecular formula, molecular weight, you can easily come to know how many times this empirical formula repeats. So that is how, if the elemental analysis will be given to you, how to solve the structure of the organic molecule by using the spectrum. So let's see a couple of more spectrum. Let me just focus on spectrum 32, which will be another simpler structure, but having something uniqueness. This will be something like 32. So this structure, I will just copy this. Now look at here. As again, just imagine this molecular formula is not given to you. So what they will give, carbon percentage, hydrogen percentage, and if not oxygen, then you can take the difference from the 100, and that is what you can easily calculate the molecular formula by considering this is the M plus value, that is a molecular weight. How many times empirical formula will repeat. So that way you can easily calculate. Now here, if you see here UV, the value provided over here, this is log to the base 10 epsilon is 4. 4 and above, that means there is a presence of conjugation. So whatever the pi bonded functional group is there, that is in conjugation. So this value is pi to pi star. Pi to pi star always have higher epsilon value. N to pi star will have lower epsilon value. That you have to remember. pi to pi star transition is always having epsilon value in thousands, maybe 10,000, 20,000. Whereas n to pi star will have lower epsilon value. So this is the simple trick to comment on this UV spectrum. Now here from this spectrum, you can easily comment that the molecule possess, and this particular spectrum shows that lambda max 241 nanometer indicates there is the presence of pi to pi star transition, which indicates there is an extended conjugation because the epsilon value is more, that is 4.1. So this is the comments on UV spectrum. Now let's comments on molecular formula. So the molecular formula is your C10H12O. So C10H12O indicates how many degree of unsaturation. This will be very easy. Carbon में एक add करो, 11 हो गया, 11 minus half of the hydrogen, so 6. So degree of unsaturation will be 5. So 5 means there is a probability to have the aromatic ring present in the molecule because 4 degree of unsaturation can be counted for this. So this one thing. So from the CMR or PMR, it is clearly indicate there is a presence of aromatic ring. So that confirms. Now, there is no doublet of doublet pattern that indicate this may be the mono-substituted aromatic ring. Okay, so normally paradise substituted pattern is for so doublet of doublet pattern, but doublet of doublet pattern doesn't look over here. So this is a complex spectrum. So that is probably a mono-substituted aromatic ring. Now in the expansion, this is a triplet. There is a triplet, and this is a multiplet. So triplet indicates that there is a presence of twice CH2 group. Okay. When triplet comes, like when twice triplet will be reflected, that means there is a presence of twice CH2 group, which is confirmed from the CMR. So there is a DPT, 2 negative peaks. So 2 CH2 groups are there. So that confirms. There is a 1 methyl group present, which is a positive peak in DPT. So that CH3 is also confirmed. That means these 3 groups are joined together. If they are joined together, so this will be triplet. This will be further will be triplet, and this middle one will be a 6, or we consider this as a multiplet. So this particular pattern can be easily confirmed from the PMR as well as from the CMR. Now, what else we can comment from IR spectrum? There is a 1686. So that means carbonyl group switching frequency is there, and no doubt this carbonyl group should be in conjugation because the epsilon value is very high. So from this structure, it is very much confirmed that aromatic ring should have in conjugation with this carbonyl group. So this you can easily comment on that. So this carbonyl group is in conjugation. That's why the stretching frequency, carbonyl stretching frequency is lower than the as usual ketonic or maybe the aldehydic stretching frequency. Now there is no aldehyde group present because we can see here there is no any 9-point stretching frequency. The del value. So there is no possibility to have aldehyde. There is no possibility to have ester. There is no possibility to have acid, or there is no possibility to have amide. So the left is ketone, and that can be easily confirmed from the C13 value. That value is 200 and something. So this 200 and something is for aldehyde, or it may be for ketone. So if there is no 9.5 value, that indicates this compound should have a ketonic carbon. So that can easily argued. No, next one. C13 NMR can give the idea about CH3, CH2, and the aromatic peak. Now, from the C13 NMR, we can easily confirm there are the 3 peaks. So if you see here, this 2 peak, and this third one. So these 2 are same, these 2 are same, and this another one is same. So that's why you will get 3 peaks, 1, 2, 3, and from that can be easily confirmed from the mono-substituted aromatic ring. So these 3 carbons, and obviously there is a bunch of peaks in proton NMR. which can be easily sorted out by the expansion, but it is not possible over here. So this will give you the doublet for these, and then middle one will give the doublet with this and doublet with this. So that double doublet and complex splitting pattern is over there. So that cannot be easily work out, but you can mention that from 7.5 to 8, there is a 2 multiplets, and that multiplet it's because of these 2 protons are same, these 2 protons are same, and this another protons are same, and they give the complex splitting pattern. So that you can easily comment from this proton NMR. Now come to the structural elucidation, that what structural units you got here so far. That you got here this aromatic ring attached to the carbonyl group, and there are 3 carbon which are in the chain. So total number of carbon atom present will be 7 plus this 3, 10. So the 10 carbon atoms are satisfied. Hydrogen number, these are 7 plus 5, again 12. And there is only one O. So what left now? The structure will be probably this, which can be confirmed from the mass. So from the mass, it can be easily confirmed by taking out one group out. Just take the difference between 120 and 148. That indicates there is a 28 units loss. That means there is a presence of alpha, beta, and gamma. Gamma hydrogen shift. That means there is a loss of olefinic group. That means McLafferty rearrangement can be easily shown by means of the structure, and that mass spectrum of the loss of 28 units clearly shows the 120 peak, followed by 105. 105 is for this unit. If the carbonyl group is attached to this, can be easily shown that one. And if the carbonyl group is gone out, the 77 is for the aromatic group. So from this structure, it is very much confirmed that this is the propyl phenyl ketone as a structure, which is confirmed from the your mass spectrum as well as C13 and rest of the data. So this is all about how to elucidate the structure by knowing the spectrum of IR, UV, NMR, mass, and C13, include DEPT. Sometimes they may give the off resonance or proton coupled spectrum wherever it's applicable. So this is all about how to elucidate the structure of the organic molecule from the spectrum. Now, what I would suggest, so in the solving the problem, somebody has already posted the one book written by a foreign author, which is I'm also referring for the solving the problem. You can solve maximum problems. If you have any doubt about solving the problems, you post the difficulties in the WhatsApp groups, and I'm there to help you out how to solve that. Okay, so I'll give the solution also. I will comments one-to-one as and when required. So if you feel that we need to practice more spectra, we will do that in a separate special session. And this WhatsApp group will be in communications for future point of view as well. Like we are going to come up with a different lecture series, including retrosynthesis, as well as some topics from your same 4 units, particularly theoretical topics, retrosynthesis, protection, deprotection, ampalong, all these topics we are going to start, but after some time. So let this particular session will be completed in a proper sense. So I think you all are happy with the spectral interpretations, what I have discussed with you, because in the beginning I have clear your idea about the spectroscopy technique, what exactly the UV spectra, what exactly the IR spectroscopy, what exactly the proton NMR, what exactly the C13 NMR, and mass spectroscopy. And then we have started solving the problems and spectral interpretations particularly. And this is applicable to part 2 student as well as part 1. Even I would say TYBSc student as well. If they are very much keen to solve the spectral problems, so this the spectra will give the data about the combined problems. which is the very important topic in case of MSc Part 1, 2, because NMR spectroscopy includes most of the combined problems, and that definitely will help you if you go through the lecture series. So soon the upcoming lectures will be intimated to you, and this is all about this workshop, which I have tried to justify that each and every student from the Mumbai University as well as from other states should be able to solve or read out the spectra, and which is very much important in terms of not to the examination as well as your future point of view. When you go to the industry, in particularly R&D, so most of the time, the students are facing the problem in characterizations. And if you do the practice and if you review my lectures, all 4 lectures, definitely will get the clicks. And I'm there to help you out. If you're having any doubt in future also about this workshop, I will be very pleased to help you out. So with this, I thank you all, my dear students, and in future, definitely we will be meeting for these next topics, that is that is this retrosynthesis, and definitely we'll enjoy that lecture too. So with this, I thank you all and wish you all the best. Thank you very much indeed. Have a great day.